Hi there. Do you still struggle with maths? Go to brilliantmaths.com. Subscribe to our YouTube channel. Watch our videos. We upload videos every week. You'll be amazed how you'll see yourself improve. Today we'll be looking at evaluating algebraic expressions, order of operations, and substitution. For the first example, evaluate minus 4 times 3 plus bracket open 16 divided by 2 squared and the bracket closes. There's a specific order in which this sum has to be done. So we need to look at that order. In some books, you'll find it as BIDMAS, meaning you focus on the bracket first, then you work on anything that concerns indices. Division and multiplication can be done side by side. Same with addition and subtraction. So the order is bracket, indices, multiplication and division, addition and subtraction. So let's look at the first example. Let's work it out now. Minus 4 times 3 plus 16 divided by 2 squared. So like we said, we're starting with the terms in the bracket. This is equal to minus 4 times 3 plus 16 divided by 2 squared. 2 squared is 4. 16 divided by 4. 16 divided by 4 is 4. So we have minus 4 times 3 plus 4. Then we can carry on now. Minus 4 times 3 is minus 12. Remember, the order is BIDMAS, bracket, indices, division and multiplication simultaneously, addition and subtraction simultaneously. Minus 4 times 3 is minus 12. So it becomes minus 12 plus 4. So that is minus 12 plus 4. And minus 12 plus 4 is minus 8. In this example, we want to evaluate 5 times 8 minus 2 in a bracket plus 7. And also to evaluate 5 squared minus 10 times minus 7 plus 20. We should remember that there is an order of operations. You can't choose to do any operation first. There's a specific order. Brackets first, if you have brackets in the expression. Indices, division and multiplication, addition and subtraction. So let's try to solve the first one. 5 times 8 minus 2 plus 7. So we focus on the bracket first, which is 8 minus 2. And 8 minus 2 is 6. So it becomes 5 times 6 plus 7. So the next is multiplication before addition. So 5 times 6 is 30. 30 plus 7 is equal to 37. If you do this sum in a different order, your answer will be wrong. Let's look at the second one. 5 squared minus 10 times minus 7 plus 20. We have 5 squared there. That indicates an index. 5 squared means 5 times 5. So that is 25 minus 10 times minus 7 plus 20. So the next step will be to multiply 10 and minus 7. And 10 times minus 7 will be equal to minus 70. I introduced this bracket so that we can work with this minus sign in front of it and be able to see what happens there. Plus 20. Minus and minus separated by a bracket is an addition. So it's like minus times minus. So it becomes 25 plus 70 plus 20. We can then add all of them together. 25 plus 70 is equal to 95. And 95 plus 20 is a 5. And 9 plus 2 is 11. So if you evaluate this, the answer will be 115 if you do it in the correct order. If your order is incorrect, your solution will be incorrect. This example says, given that x is equal to minus 5, y is equal to 7, and z is equal to minus 11, find the values of the following expressions. We want to find the value of the expression when x is minus 5, y is 7, and z is minus 11. So for the first one, anywhere you find x, you replace your x with minus 5, because the value of x is minus 5. And where you find y, you replace it with 7. So let's see. 3x plus 4y is equal to 3 times minus 5 plus 4 times 7. This is equal to 3 times minus 5 is minus 15 plus 4 times 7 is 28. The final answer will be 28 minus 15. And 28 minus 15 is equal to 13. This is what we call substitution. We've substituted the values of x and y to get an exact value for the expression 3s plus 4y. In the second example, x minus y squared minus 3z is our expression. So let's substitute. X is equal to minus 5. So we have minus 5. Y is equal to 7. So y squared will be 7 squared. So minus 7 squared. The next thing we need to do is multiply 3 by the value of z. And z is minus 11. Having done that, we have minus 5 minus 7 squared is 49. And minus 3 times minus 11 is plus 33. The next step, minus 5 minus 49 is minus 54. And then minus 54 plus 33. 54 as a number is greater than 33, so our answer will definitely have a minus sign. 54 take away 33 will be 21. So the answer is minus 21. We want to evaluate the following algebraic expressions when a is 4, b is minus 2, and c is minus 3. The first one is the square root of ab plus c squared. A is 4. So we have 4 times minus 2 plus 3 squared. And this will give us 4 times minus 2 will be minus 8. 4 times minus 2 will be minus 8. And minus 3 squared will be 9. So we have square root of 8 plus 9. Minus 8 plus 9. That will be equal to square root of 1, which is equal to 1. In the next example, 5c into bracket a minus b minus c, bracket close. Let's substitute the values. C is minus 3, so we have 5 times minus 3 into A is 4 minus B, and B is minus 2. So we have 2 negative signs there, minus C. Again, C is minus 3. And there we have a bigger bracket. So minus 5 times minus 3 is minus 15. Let's look at this closely. It becomes 4. Minus minus is plus. Minus minus is plus. So we have 4 plus 2 plus 3. 2 plus 3 is 5, and 5 plus 4 is 9. The answer is going to be 15 times 9. And 15 times 9 is equal to 9 times 5 is 45, carry 4. 9 times 1 is 9, plus 4, 13. So the final answer is minus 135. In this example, we're still substituting. A is 4, B is minus 2, and C is minus 3. This will be equal to 2 times 4 minus 2 all over 2c. That is 2 times minus 3. So this will give us 2 times 4 is 8. Minus times minus is plus. So 8 plus 2 will be 10. And 2 times minus 3 will be minus 6. We can reduce this to lowest terms. We divide both numerator and denominator by 2, and our final answer will be minus 5 over 3. And for the last example, minus b plus c is in a bracket, and we're multiplying that by a squared. B is minus 2, so we have minus 2 plus c is minus 3, minus 3. A is 4. So a squared, A is 4. So a squared is 16. In the bracket, we have minus times minus 2 is plus 2. So that gives us plus 2. Plus times minus 3 is minus 3 times 16. So this becomes minus 1 times 16, which is equal to minus 16. We want to look at factorization of algebraic expressions. Factorization is the reverse or opposite of expansion. That means if you factorize, for example, 8x squared plus 12xy. Whatever you get, if you expand it, you will get 8x squared plus 12xy. Let's try that out. So to factorize that, we have 8x squared plus 12xy. We want to find the highest common factor of the two terms. The highest common factor of 8 and 12 is 4. So we take out 4. We factorize 4. 4 into 8 is 2. 4 into 12 is 3. Let's go. X squared and x. So x is a common term. So we factorize x. So x squared divided by x, we have an x. X divided by x, they cancel out, and then we have 3y left. So if you factorize 8x squared plus 12xy, your answer is 4x into 2x plus 3y. Let's see what we mean by factorization is the reverse of expansion. Let's expand this term now and see if we will get 8x squared plus 12xy. So let's check. We're expanding 4x into 2x plus 3y. We multiply. 4x times 2x will give us 8x squared plus 4x times plus 3y will give us 12xy. And that is the same as the original question we had. So we can confidently say that factorization is the reverse or opposite of expansion. Here we want to factorize 17p squared minus 34p. We want to find the highest common factor of 17p squared and 34p. What is common? Double 17 is equal to 34. So 17 is common. We factorize it out. And then we have p squared here, and we have p. So p is also common. So we divide each of these terms by the highest common factor, which we have found. The highest common factor here is 17p. So 17p squared divided by 17p would leave us with p inside the bracket minus 34p divided by 17p would give 2. So the answer is 17p into p minus 2. We mentioned earlier on that factorization is the opposite of expansion. We can quickly check that mentally. 17p times p will give us 17p squared. And 17p times minus 2 will give us minus 34p. So indeed, factorization is the reverse of expansion. For example 2, we have 6ab plus 9ba plus 3bd. What is common to all three terms? 3 is common, so we factorize it out. We're going to divide each of these terms by the factors. The first factor we found is 3. Let's find another one. A, but no A. So A is not a common factor. B. So B is a common factor. We factorize it out also. So let's divide each term and see what we are left with. 6ab divided by 3b will give us 2a plus 9BA divided by 3B. 9 divided by 3 will be 3. So that will leave us with 3A. And 3BD divided by 3B would leave us with D. So the answer is 3B into 2A plus 3A plus D. You could check that out yourself to see that factorization is the reverse of expansion. Expand this and see that you will get the original expression. In this next example, we have x cubed y squared minus 3xyz. We're looking for the highest common factor of the two terms. This is x cubed, and here we have an x. So 1x is common. This is y squared, and here we have a y. So y is also common. So we're going to divide each of these terms by xy. If we divide x cubed y squared by xy, we would have x squared y minus, if we divide 3xyz by xy, we'll be left with 3z. And that's our answer. And for the last example here, ax squared y minus 2ax squared z. Highest common factor. A is common to both, so we factorize it out. X squared is common to both, factorize out x squared, and then divide each of these terms by highest common factor. Ax squared y divided by ax squared will give us y minus 2ax squared z divided by ax squared will leave us with 2z. So the answer becomes ax squared outside the bracket, or to multiply the bracket with y minus 2z. In this example, we want to factorize 3pqx plus 3pq squared plus 3p squared q. And in order to factorize, we need to find the highest common factor of the three terms. As we can see, 3 is common to each of them. So we factorize out 3. Let's look for another common factor. P is common because we have p here and p there, and we have p squared there. So p is a common factor. Do we have another common factor? Look at it and let's see. There's a q here, there's a q squared here, and there's a q here. So q is also common. Do we have any other common factor? There's an x here, no x, no x. So that's it. We're going to divide each of these terms by the highest common factor, 3pq. So 3pqx divided by 3pq will leave us with just x plus 3pq squared divided by 3pq would leave us with q plus 3p squared q divided by 3pq would leave us with a p. So that our answer becomes 3pq into bracket x plus q plus p bracket close. And again, you can try that out, expand it, and you see that you would get the original expression. In the next example, we have xyz plus y cubed z minus 4y squared z squared. What is common? There's an x here. There's no x here, no x there, so x is not common. Y cubed, y squared. So y is common. We factorize it out. Y. What else is common? We have a z here, a z there, and a z squared. So z is also common. So now let's divide. So xyz divided by yz leaves us with an x plus y cubed z divided by yz leaves us with y squared minus 4y squared z squared divided by yz leaves us with 4yz. So our final answer is yz into x plus y squared minus 4yz. I am Ngozi Orevogene. Subscribe to brilliantmaths.com for excellent performance in math. Subscribe to our YouTube channel, watch the videos, share with your friends, and you will see how well you will improve. And always remember, maths is fun, and you can do it.